Hey everybody. We're gonna start moving into the next unit, Unit 8. We're moving into our solar system unit. Just wanted to let you know really quick, I have a little bit of a raspy voice just because I lost it over the weekend. So just note that I sound a little different, but it's still me. So here we go. We're gonna start moving into our solar system unit where we talk about the planets. So I wanted to point out to you that this slideshow of the planets, it mentions gravity, but we're not going to cover, you can do your notes on gravity today, but we're really not going to cover it till next week. So when we talk about the planets, we're going to start with the inner planets and then move to the outer planets. So let's go to these notes. You're going to want to open your digital notebook and you're going to want to go to page 20. On page 20, you can see I even pulled up the key to the notes. I do not have the sun filled in yet. I'll get that filled in, but I mean, you could even put in here, it's like the center. I'll even write on here the center of our solar system just to kind of get you started. But just so you know, these are your notes. The key is here. So make sure if you need to, pause the video and fill in your notes. Don't just keep watching to watch it. Pause the video, fill in your notes, and then watch and listen. So I can go ahead and zoom in a bit for you. But the beginning of the slideshow, and you can go to the slideshow if you want. I'm just not going to click too much back and forth and whatnot. But we just need to cover what a planet is. It's this body in space that moves in the solar system. So I'm going to draw a quick picture. Let's get my little pen here. All right. So just to let you know, this is the sun in the middle of our solar system. And then let's say this is planet Earth. All right. So we have Earth. I'm going to put an E here for Earth. Okay. I do want to let you know that each planet will do something on its axis. It's called rotate. It's going to rotate on its axis. Each planet takes a certain amount of time to rotate on the axis. For planet Earth, we take 24 hours. Hence the reason why it's spinning on its axis. And as the sun is on this tilt, it's tilted towards the sun. And then when it spins, you know, the side that's facing the sun is going to eventually face the other side of the sun, and then the other side of the sun will face the sun. So it does spin on its axis, which is called rotating. And then as it does that, it's also moving in the solar system on a pathway. It's moving in more of an elliptical orbit. And that's not the most perfect drawing, but it's moving in an elliptical orbit around the sun. Each planet will have its own pathway. For example, for Earth, this is, you can say orbiting, many people do. Another word is that we say is it's revolving around the sun, revolving. When it completes one full revolution around the sun, that is 365 days, which is a year. That's where we get our year from, okay? So I wanted to let you know about all that. So it revolves around the sun, and one revolution is 365 days, 1 year. The only other word I wanted to talk to you about is the actual path. Like it's not a circle that it takes. It's more of like this oval-y shape, and that is called an ellipse. Not an eclipse, but an ellipse, like ELLIPSE. That's just the term for its pathway around the sun. All right. So let's go ahead and erase that and continue on with the planets. Let's see. Some characteristics about planets. Each planet will have its own color, its own proximity to the sun, the size of it, the speed of which it travels. Every planet has its own density too. We'll talk about that in a little bit. And it's going to have certain physical and chemical makeup, like kind of when we talked about physical and chemical changes, alrighty? I did tell you that years ago like the past few years, the kids did physical notebooks, and we're doing digital ones this year. But we are going to take a look more in depth at our inner planets. You're going to do an activity next week where you really do look at the inner planets and with regards to comparison with the outer planets when we get there. But our 4 inner planets are Mercury, Venus, Earth, and Mars. Mercury is going to be the closest to the sun, then Venus, then Earth, and then Mars. These planets are a lot closer together. They're terrestrial, which means we can go there and, like, we can't go there, but we can, if we were able to, we can go there and we can walk on them because they're rocky. We will not go right through them. They're not gas giants, nothing like that, okay? They will be more dense, meaning if you were to put them, if they were able to fit into a tub of water, more than likely a lot of them will sink, all right, because they're more dense. They're going to be smaller than the gas giants. The gas giants are massive when we talk about those, which are the outer planets. So these inner planets are a lot smaller, and then their revolution around the sun is going to be a lot shorter than the gas giants. Okay, so the outer planets, again, compared to the inner planets, we will talk about this when we get to the outer planets, but we're just going to focus on the inner ones today. So on the notes, you can, if you want to take the time, you can go ahead and fill out everything, like everything, but you don't have to fill out the outer planets until I make that video on the outer planets, alrighty? The part that I had just read to you about more dense, smaller, etc. is right here, so you could fill that in. The part about the planets in general is right here. You can pause the video and fill this in because we did talk about that already. So again, when we get to gravity, we'll go back and fill that in, so you don't have to worry about that just yet. We're going to kind of jump around this unit, so you might not have a full page completed before we move on to page 21, but just note we will, okay? So let's go ahead and move to our first planet, and that will be Mercury, okay? So this is the planet that's closest to the sun, and you want to get to, and I need to edit that because it says solary, but we need to get to Mercury, okay? It's right here. For Mercury, you can kind of see the notes, and you can pause and write it down in that section if you want. But just to kind of give you a little bit of a tidbit about Mercury. Mercury is going to be the closest planet to the sun. It's the smallest planet in the solar system, and it's the second hottest planet. I will tell you, Mercury is like a crazy planet. It's crazy. We have a really good atmosphere here on Earth with our greenhouse effect where we can trap heat, but it's not too hot. It's where life can be sustained. On Mercury, there's no atmosphere, meaning it goes from crazy high temperatures, like burning hot, to really, really cold, just like that. So there's no, like, it's crazy. We'll just put it that way. So in all honesty, no human is going to be able to go to Mercury, all right? At times, this planet can get way hotter than Venus, to be honest, but it's not considered the hottest planet because it can go crazy cold, just like that. So it just doesn't sustain that heat. So it's really just a nutsy planet. That's a Mercury. But again, no human can really go there because of those crazy no atmosphere and temperature changes. We take 365 days, and the revolution for Mercury to go around the sun is just 88 days. So it's cruising, okay? Craters, it does have craters, like these like little, if you ever seen like videos on craters that may have hit the earth and stuff, we'll talk about those when we get to meteors, but they're like little divots in the earth kind of thing. I always think of like a golf course, if you will, when I think of craters. It's like kind of like the sand on a golf course, so I kind of think of it that way. But that's Mercury. When we move on to Venus, this is going to be the second planet that's closest to the sun. Venus is considered really the hottest planet because it's very consistently super, super extremely hot. I think it can go upwards, like you think of an oven, like at 400 or 450 degrees, like that's burning hot. This is like way hotter. So I would watch like the Science Channel with my husband mainly he would watch it because he loves learning about the planets. But with me, I just like started to pick up on some of this extra information stuff. But Venus is literally considered the sister to Earth because of its size. Venus and Earth are pretty similar in size. They're the hottest. Venus is going to be your hottest planet because it does have like a crazy good greenhouse effect where it traps heat so insanely hot that, to tell you the truth, on Venus it rains metal at times. Like, it's that hot. I heard on the Science Channel, and do not do this at home, but on Venus it gets so hot that if you were to heat up an oven to 450 degrees and like put your hand or like head or something inside just to feel the heat, don't do it. But if you were to like imagine doing that, it's not hot enough. Venus is going to be that much hotter. It takes, like, we take 365 days. Venus is going to take 243 days to go around the sun. And Venus is just like, if you could imagine like hell, pretty much, this is gonna be Venus. Venus is insane. And no human can go there because they would be crushed before it even reached the surface of the atmosphere. That's how thick its atmosphere is. It's thick and just blah. When we talk about Earth, that's our home. It's mainly water. It's the only planet so far that can sustain intelligent life like us, okay, and other organisms. We are protected from the sun on Venus because we have a magnetosphere. We don't really learn about that much in 6th grade, but we are protected because there's different layers to our atmosphere, and we have a nice greenhouse effect here that can sustain life. Okay, so we are protected from the sun and all that good stuff, and we have nice weather here. So this is our home planet. And then last but not least, when we move into Mars, Mars is going to be the red planet. You guys know that life was pretty much like found on Mars from the rovers they've sent there, but it's not intelligent life like me and you. It's going to be like like a bacteria. Okay, like those are living, but they're like single-celled organisms, like very, very microscopic. There's like the Grand Canyon for us. There's going to be canyons on Mars. It has crazy, huge dust storms. It has an unmanned, like we've sent unmanned, like meaning it's just a robot rovers to Mars. And like we take 365 days to go around the Earth. Mars takes 687 days. So that's like over double of what, maybe not over double, but like almost double of what we take. So yeah, just remember, if you see like that red planet, that's Mars. Mars also has 2 moons. Like we have the moon. Mars has 2 moons to it, okay? Mercury will not have any, I believe. And then Venus has 1, I believe. So in total, no. Mercury and Venus do not have any moons. None. These 2 don't have any. And then Mars has 2 and Earth has 1. So in total, the inner planets just have 3 moons between all 4 of them. So 2 on Mars and just 1 on Earth. All right? On your notes, the inner planets, just make sure you fill in Mercury, Venus, and then Earth and Mars are up here in the green. So make sure you fill that in, and we'll move on to the 4 outer planets in the next video.